Hello students, welcome back to the second video of this playlist. So in this video we will be solving the second question from June 2023 P4 paper. So let's see what they have asked in question number 2 of P4 June 2023 paper. Okay. So question number 2, if I give a small review on question number 2, basically question number 2 it's from differentiation part of P4. To be more specific, question 2 consists of implicit differentiation process, and in the second part it's something related to finding the equation of tangent and stuffs like that. Okay, so let's get started. So right at first you can see in question number 2 there is a figure. You can see a figure given. That's a curve. You can see a sketch of a curve. So the equation of curve C, it's an implicit equation. It's given by 2 to the power x negative 4xy plus y squared equals to 13. The range of possible values for y is given. Okay, the point P, you can see the point P is there on the curve. Okay, lies on C and has x coordinate what, 2. At point P the value for x is what? The value for x is 2. Fine. Find the y coordinate of P. We need the y coordinate of point P. So this is very straightforward question, like finding the coordinate of a point that lies on a curve, whereas the equation of the curve is already given. So you just plug in the value for x, that is x equals to 2, into the equation of the curve. You will directly get the y coordinate. So let's do that. For part A, what we will do, we will just put x equals to 2 into the equation of the curve. So what we will get, 2 squared, that is 4 negative 8y, right? 8y plus y squared equals to what? 13. So take all the terms with on the same side. It will form a quadratic equation. So y squared plus what? It's not plus, it's positive, it's negative, sorry. So it's negative, so negative 8y, take 13 to the left. Take 13 to the left, so what we will get? Negative 9 equals to what? 0. So what we can do, that's a quadratic equation, we can do middle term, isn't it? So that would give you what? Y squared minus 9y plus y negative 9 equals to what? 0. Fine. So y times what? Y minus 9 plus 1 times y minus 9. Done. We got two possible values for y. So which one we should consider? In order to consider, we need to see the question, like what they have said the range of possible values for y. You can see that they said y greater than 9, right? Sorry, y greater than 0. That's why we should consider what? Y equals to 9, right? As y greater than 0. Done. That's all about part A. Next, for part B, find derivative of y in terms of x and y. Derivative of y in terms of x and y. So this is very straightforward. Like they asked to find the derivative, the gradient function of the curve in terms of both x and y. So like it's very easy to understand that in this type of question, like when they ask to find the derivative in terms of both x and y, we have to use implicit differentiation. So let's do implicit differentiation and let's find out the derivative of this curve. So if you see this equation, 2 to the power x negative 4xy plus y squared equals to 13. So for part B, the equation, let me write the equation at first since it's in the previous page. So 2 to the power x, then negative 4xy plus y squared. Okay, negative 4xy plus y squared equals to what? 13. Okay, this is the equation of the curve. Okay, so what we can do now is that we need to differentiate, right? So what we can do, we are using what? Implicit differentiation, isn't it? Using implicit differentiation. Okay, we are using implicit differentiation. Okay, so the derivative of 2 to the power x, what it would be? What would be the derivative of 2 to the power x? Do you know? It's you are supposed to know if you have done P3 differentiation. Then we have learned from P3 differentiation that the derivative of 2 to the power x, this is an exponential term. Okay, so for that term, its derivative is ln 2 times 2 to the power x. Fine. The base is 2 here, so you will just put ln 2, and then we know that the property of an exponential curve is that their derivative is itself. Okay, so this is for exponential. This is, you can say, exponential. You can say this 2 to the power x is also an exponential equation, exponential term. So for exponential terms, there is a common property that exponential terms has their derivative itself. So in that case, since there is a constant 2, we have to use what? Chain rule here in that case to differentiate 2 to the power x. So we got ln 2, that's the constant, comes to be multiplied with 2 to the power x. So look, the derivative is what? Isn't it itself? Because we got 2 to the power x in its derivative. So it's remaining itself, but just we are multiplying with ln 2. Fine. Now next is negative 4xy. So in that case, x times y, right? You can see that two different terms are in multiplication form. So in that case, what we need to do is that we need to use product rule, isn't it? So we will consider u equals to x and v equals to what? Y. Now we will simultaneously differentiate both. So what you will get? dv over dy equals to what? 1. But there's a thing you need to consider. Generally in differentiation, what we do, we differentiate x, but in implicit differentiation we need to also differentiate y. So while you differentiate y, you need to keep in mind, like after differentiating, we will differentiate y as how do we differentiate x, the same process, but we need to do some extra thing here, is that after finding the derivative, you just need to multiply the derivative of y with dy over dx. Okay, so like here the derivative of y is what? 1. So 1 times dy over dx. That's it, simple process. So now product rule, so cross multiply, right? And then we will add them up. So what we will get? X dy over dx plus what? Just y equals to y squared. The derivative of y squared is what? Twice of y, but it is what? We are differentiating y, so we need to multiply by dy over dx equals to what? The derivative of 13 is 0, since it's a constant. So what we need to do is that now multiply out the brackets, and then we will go for the next step. So for x dy over dx minus 4y, it should be the derivative of y squared is what? Twice of y, isn't it? I think I did a mistake there. Just hold a bit. Here, let me pick an eraser. It should be not equal. It should be what? It should be plus, isn't it? So we got negative 4y plus 2y dy over dx equals to what? 0. Now just you need to make dy over dx the subject. So what you will get? You will get, and take the other terms to the right side, you will get, if negative 4y is taken to the right, you will get 4y, and 2 to the power x ln 2, if it is taken to the right, you will get negative twice to the power x ln 2, right, over what, 2y minus 4x. That's it. We got the derivative of this curve in terms of both x and y. That's it. Okay. Next is for part C. Next is part C. So for part C, the tangent to C at P crosses the x-axis at the point Q. Okay. The tangent to the curve C at point P. If we draw a tangent to the curve C at point P, okay, this tangent, let me draw a tangent. This tangent will basically intersect the y-axis at where? This is the tangent. So it will intersect the x-axis. Is it x-axis or the y-axis? It's the x-axis. Okay. It will intersect the x-axis like here. So we need to find out the x coordinate of this point. Fine. So how can we do that? At first, consider some concepts that we know. Okay. Tangent. Basically, a tangent intersects a curve at a single point. And we know a property of a tangent is that the gradient of a tangent is the same as the gradient of the curve at that specific point where the tangent is intersecting the curve, right? So that means, since we know the derivative of this curve, the gradient function of this curve, so if we substitute the coordinates of xy, why we need to use xy, coordinates of xy, because this is an implicit derivative, isn't it? So in that case we need both x and y coordinate. So if you just put the x and y coordinate in the derivative, you will be getting the gradient. That means if you get the gradient of the curve, basically you are getting the gradient of the tangent. That's it. So let's find out the gradient of the curve at point P. That would be the gradient of the what? Tangent, isn't it? So we know the coordinates of point P, which is x equals to 2 and y equals to 9, isn't it? So x2, the value for y is what? 9. Okay. So what would be the value for the derivative? Let's plug in the values. 4y. 4y is 36. Negative 2 to the power x is 4 ln 2 over what? 2y is 18 minus 4x is what? 8. So what you will get? 36 minus 4 ln 2 over 18 minus 8, that is 10. Should we simplify more? We can. Like 36 over 10, that can be written as 18 over 5 minus what? 2 over 5 ln 2. That's it. We got the gradient basically. So this is the derivative of what? This is the value for the gradient of the curve C at point P. So this is the gradient of the tangent 2. Okay. So what you will get? We will be getting the gradient is 18 over 5 negative what? 2 over 5 ln 2. I think you don't need to simplify it. If you keep it as it is, it's enough. It will be just waste of time. Okay. Just find out the equation of tangent. Let's do this first. Equation of the tangent. It would be what? Y minus y1 equals to gradient. Gradient was what? 36 minus 4 ln 2 over what? 10. M times x minus what? 2. Isn't it? The equation for straight line. So what we can do now is that we just need to make x the subject, right? So let's multiply out the brackets. What you will get? 36 minus 4 ln 2 over what? 10 x minus what? 36 minus 4 ln 2 over 5. Just we need to make what? X the subject. So if you want to make the X the subject, just keep in mind we need to find out the point where the line is intersecting the x-axis, right? So this is the equation what we got there. This is the equation what we have got there. So we will do just substitute y equals to 0, because at the x-axis, okay, at the x-axis the value for y is what? 0. So we can write it at x-axis. What we know? Y equals to what? Y equals to 0. So let's erase y. So we'll get negative 9 equals to this. So from there we need to make x the subject. So keep x on one side. 4 ln 2 over 10. X equals to what? 36 minus 4 ln 2 over what? 5, right? Minus 9. Now what we need to do, we can multiply both sides by 10. If we do so, what you will get? 36 minus 4 ln 2 x equals to what? 36 times 2, that would be 72, negative what? 8 ln 2 minus what? 90. Fine. So what's next? Okay, so now we need to make x the subject. Let me expand the page. Okay, we need to make x the subject. So if you make x the subject, what you will get? Negative 8 ln 2 minus 18 over what? 36 minus what? 4 ln 2. So if you keep it as it is, I think you can simplify it more. How can we simplify it? Take negative 1 common from the top. So you will get 8 ln 2 plus 18, and from the denominator multiply this negative in the denominator. So you will get 4 ln 2 minus 36. You can see that there is 2 common, right? We can simplify by dividing 2 both at the denominator and the numerator. So you will get 4 ln 2 plus 9, 4 ln 2 plus 9 over what? You will get 2 ln 2 minus what? 18. Fine. Just multiply negative 1 at the bottom by taking negative 1 common at the top, and this is the value for what? The x coordinate of the intersection with the x-axis. Okay, so we need the value for a, b, c, d. Okay, a, b, c, d are integers to be found. So the value for a is what? A ln 2, right? That was a ln 2. That means a equals to 4, b equals to 9, c equals to what? 2, and d equals to what? Negative 18. That's it. These are the values for a, b, c, and what? D. And that's all about the second question from June 2023 P4 paper.